Hello, everyone. How are you? How you doing? The temperature here is in the minus for both the Fahrenheit scale and the Celsius scale. So we got around minus 20. That is, I think, -4 Fahrenheit. So it's all good. The skin is getting nice and fresh again. You know, it's good for the skin. And plus, uh, just because no one asked me, I have contractors here. So if you hear any banging, any cutting, any weird noises, that is not me. It is the contractors. They're destroying my house in order to make it a bit better. Anyhow, I hope everyone's okay. And I don't know how many of you joined the show yesterday where Ellie and Jonas showed the new features that we are going to geek out today and show you some interesting stuff. Very good questions coming through. So, yeah, I'm going to go down my rabbit holes and see what comes out the other side. But I have something to say. I have a little surprise for you. I know I promised a while ago. By the way, let's. So here's a nice question. Let me just bring up some comments. Ouch, where are you? Well, I live in Canada, and now I'm in the beautiful Laurentians in Quebec, the province of Quebec. So, yeah, it's a little ski town here. And despite the cold, it's one of the most beautiful places to be. And yeah, we have a beautiful view outside our windows. And that's what. Oh, Alberta. Yep. You think this is cold? Why don't you go to Alberta and see what happens there? Huge respect to Thompson X. And I love Alberta, especially the mountainous side. I've never been there yet. Excellent. So let's what did I want to say? Oh yeah. So I have a surprise for you. All right. So this was inspired by a lot of you that ask really cool questions, and I create a project file, and then it's a bit of a, we had that method. Anyway, I have done something, and I want you to. I'm going to paste a link. I need to go and find it now, and the link is. Let me find the link because there we go. So I'm going to go and I'm going to paste this link in the chat. And I want everyone to click on it. Just go click, click, clickety click. Come on, mouse buttons and all that. Clickety click. And this is the first stage. If anyone has a problem, tell me, because this is something we're piloting here. And you should see a very simple but nice little downloads page here. And let's see. Good. So what is this? Right. Let me share my screen. Right. Let me share my screen. Let me go here. Boot. There we go. So you should be seeing this page over here. And you can see we have some folders. And this is a place where all sorts of project files will, thumbnails and all that. I don't know. I need to see technologically how that can be done. But nonetheless, this is a look behind the scenes for you. We are going to throw random files. So for the various shows, here are some of the things I'm going to show today. I need to update, I think. Yep. There you go. There you go. So make sure you update this and visit this page quite often. The training team and others are going to drop various test files here. So this is a nice place for you to go and explore. Over then I'd say in the short and midterm, we're going to add other links. So for people that want to learn about other things, you'll find links to Cineverse and so forth. Now it's just a self-contained little page, but this will allow me, I can actually on the spot while I'm talking to you, if I create a file, I can drop it onto this onto this repository, and you will have access to it within a few seconds, providing you just refresh your little page. That's all you have to do. So we are going to try, and Ellie was kind enough to share the files from 2024 and 2025. So, oops, yeah, this is the back you need to click. And Donovan gave me a little project here. And here are some random experiments I've been doing lately. So you may be able to follow. So the way this is going to work is that any questions you ask, I cannot share. So one thing you need to understand about the legality of certain things, if you send me a file and I take a look and that file contains a model or something you've made, I cannot distribute this. I will not distribute it. It's that is not our own intellectual property. On this downloads page, you will only find things that we have made from scratch or stuff that exists in the asset browser. We will not repost other people's work. Even if you give us permission, we cannot do that, but because we cannot, so that you have a better understanding. If you give me a model you made, a sculpt or anything like that, and say, share it with the community, as grateful as we and the community may be, we do not know if that original model was made by you. And it only takes one misstep for this whole thing to come crashing down and everyone getting in trouble. So as far as the experiments me and my colleagues are doing, things are going to find their place here. Quick tips now. We have a very quick way of sharing quick tip files and so forth. And this is open for you. You can visit this every few days and check and see if there's anything else available to download. And yeah, so this is the first step to do something to come closer to you and make our relationship a bit more interactive. Okay, we went, we had issues with our relationship. We went to counseling, and now, we will talk these things over. So see this, think of this as us taking a step closer to you. Excellent, good. And any ideas and all that are always welcome. Okay, so this was my little surprise for today. Let's move on to various questions and all sorts of let's see, all sorts of other things. So what do I do now? Yeah, I will put this down because I'm going to do my my housekeeping later on. So let's go to the questions. So someone said here, or how do we do a Fibonacci thingy-madoodle? Anyway, I lost the question over here. Now, this is not using the new distributions, right? Because I assume that not everyone is following everything I've done over the years. So this was part of a project that started with a motion tour, I think 2019 or something like that, where Perception New York created a beautiful animation for Maxon. And I was traveling around our little 3D motion tour circus and presenting certain ways. So what you see here is a standard way of creating an animated flower that complies to the golden ratio, 100 and something point something. You can always go to Wikipedia. So there you go, chrysanthemum, whatever. And you will find this file in the downloads. Yoo-hoo! In today's, that's what I like about this, in today's date. Okay, so go download it, do whatever you want. I created this from scratch, so you might as well just, oh, and it, by the way, this is standard render because it was done, when was it done? Right, let's find out. Something from 2026. Oh, I've opened it ever since. I may have copied and pasted it, 2026.1. Anyhow, there you go. Golden ratio, Fibonacci. Of course, we can do this using the new distributions, but I'm not going to do it right now. play with this, and we'll see what we'll do later on. Okay. Boom. Bye. Okay. Let's go to the first questions. There we go. This is the question. Beach Mobile, Mob Jellies. Beach Mob Jellies. Okay. Sorry, I thought this was a French name. Hey, Noseman. You bringeth forth a question. How do I rig up custom user data and so forth? Now, it's been showed a few times. In the old Redshift XPresso shader graph, you could actually drag an object, and because it's XPresso, it can do it can extract the data. And let me remove my face from there. There we go. You can extract the data, but for the new node system, you do need to do an extra step. And I know it's not extremely convenient, but it allows you to do certain things per object. So first of all, in the material, you need a user data. Depending on the type of data you're trying to use, you either use, if you go press C and type user, you will see the user data color, integer, scalar, string. That doesn't work. Maybe it does. I'm not absolutely sure. I'm not sure. It potentially does work in certain setups, and vector. So for what I want to do here, so we're going to use this, and I'll tell you what this division is. It's just to change the relationship of the numbers. Anyway, select your object and go create a user data. And you know something? I'm just going to create a new scene and do it from scratch. What is the idea? The idea is that I want to move this up and down from, let's say, 0 to 100. And I want the color to go from black to white while I'm moving it from 0 to 100. So I want to use the Y value of the position and to colorize this from 0 to 100. Okay, you can go above that, and the numbers, the values are going to go above the high dynamic range 1. Excellent. So let's do that. You have to go, sorry, not right click, select the object, go user data, and add some user data. I'm going to call this whatever. You can call it whatever you want, height. And make sure you copy this name. Now, there's a certain convention in Cinema 4D, you don't have to follow it. But because something else may be named height, which, again, it's not going to interfere, but this is sort of a programmatic approach to things. If you put a double underscore before and a double underscore after, you're eliminating this coming from a parameter called height from something else. We don't, but you can start developing these kind of habits to make sure that your code or whatever you do is going to be a bit more robust and fail-safe. So copy. I'm copying the name. Now I need to set my data. So this is a float. It's just a normal number. It's not a percentage. It's a length unit or a real number, nothing else. And you can set limit, min, max, and you can put sliders and all that kind of stuff. I'm going to limit it to 100. You don't have to, but you could. Good. Press OK. So now this cube has this user data called height. Okay. And you can put numbers from 0 to 100. There you go. You have a little interface and all that. Now, I want to transfer this to a shader. So go create any material, go to the material, type C user data. So I want this as an integer. And I'm just going to pipe it directly to the surface. So I just get black and white. And what you need to do here, you won't find it in the presets. You need to go here and paste the name of that value. And that's pretty much it now. What we should see, well, you have to apply the material, but that is, I think, yeah. Okay, let's see what's going to happen here. I'm going to show you how this may become a bit problematic, because you can see it's definitely white here. Oh, sorry. I did a mistake. We have this tied to the user data, not to the height, right? So if I move this, make this, let's say 0, you'll see it's black. If I make this 0.5, it's going to be gray, okay? And if I make it 1, it's going to be bright. Let's say 0.1, 0.2, come on, 0.4. Why isn't it height? 0.4. I've got this applied to this. Why isn't this changing? Changing if I go increment 1. I think it's because, I think this is my mistake. I think it's because manage user data, I set the step to be 1. Okay, so and I'm going to make it a bit smaller now. So let's see if this is going to work. It should give us gray values from 0 to 1. I do not believe why this is not. Oh, okay. So lesson number 1, when you want to float, choose a float, not an integer. User error, I said integer, and I wanted a scalar. Okay, I know what my brain did now. Because I call them floats, but Redshift calls them scalars, it just messed with my mind. And anyway, now it's going to work. So 0.2, there you go. 0.1, there you go. So we have this value now from 0 to 1, which gives us color from 0 to 1. I want to tie my height to this. Well, this you need to do it using XPresso. So you would go and you would say, let's get an XPresso tag. Let's bring this cube in here twice, and let's take the the Y position and go to user data and say, let's get the height here. Okay, so I want this number to change from 0 to 100 to go from 0 to 1. And yeah, you will use a range mapper. And you would say from 0 to 1, go 0, from 0 to 100, sorry. The input, go 0 to 1. Now it should work. Go up, there we go. From 0, there we go. And depending how high I go, it changes color. And that's pretty much how you are going to do this. Yeah, integers are round numbers. Float numbers have decimal increments. Yeah. So this is an interesting one. Let me go down here. There we go. So when is the float, and does it round to the nearest? It kind of. It's just what the data sees. So if you, I think it rounds up. I think it rounds up always. So if you use 0.2, it will round up to 1 or something like that. Anyhow, this is how you do this. And I think that there's a file in the uploads already there. Now, I did the translation here with a range mapper where it takes the value from 0 to 100y and converts it to 0 to 1 in the, let's say, luminance now for this. Here, I did it another way. My connection with the user data is direct, 1 to 1, but I do the division in the material. So I'm taking whatever this value is, I'm dividing it by 100. So 0 to, so I'm going to take that value of 100 centimeters, divide it by 100. So that will be 1% brightness. Anyway, the file is there for you to go and test. And while it may be not as simple as just dragging it, it is a way of doing things. Oh, one thing you need to remember is that if you add another object here without the user data, you won't be able to use the same material. It will render black. So this is per object. Okay, let's go a few questions and then we can play around with nodes and stuff like that. Okay, I'm going to go up. Let's see. Where are we? Good mornings and all that. Okay, let's start with this. Would love to see how to make a circle packing distribution for the new cloner. Okay, first of all, it's not a new cloner. You all know that. We're just going to try and keep the terminology, as simple as possible. I will. Let me think what I can start, the best way I can start. Right, I'm going to start with a blank scene, and I'm going to tell you how you begin making your own custom distribution. And we're going to create something extremely simple. Okay? So, is everyone ready for this? I want at least 5 yes or okays to proceed. I'm going to put my face up here. I know I'm just teasing you there, but I want confirmation. So, ready? Thompson X, ready? I need 4 more to go. Yes. Sorab, good one. Sorab votes twice. Good. And here we go. Fantastic. Okay, we can go now. Sorry, I tease you. I just enjoy doing that. Okay, create a cloner and add as many clones as you wish. There is no limit to this, and it's good to start with a certain number because we're going to treat them like normal clones without any problem whatsoever. Okay, so I've got these three clones. You don't need clones. I'm just putting them here so you can see the various behaviors unfold. You set to advanced, and then you can always browse and get one of the built-in. You're going to find distributions if you create your own assets and you have set them as distributions. So that will be populated with anything you do make. But create will give us an empty distribution. I have my own little nodes layout. And basically, the cloner now has changed ever so slightly. Let me open this up, show you what changes have happened here. It's changed. It says clones from distribution. And that means that there's this weird thing here called clone type, which doesn't mean clone type. It means which clone we're going to select. That's what it means. It says clone type. Let's all accept it. And, it's you always love your children. Doesn't matter how ugly they are. Okay. So clone type means which of these clones we're going to get. And this means that anything, remember a clone has iterate and random and all that, that is going to be determined by the distribution itself. Okay, so that's just about it when it comes to that. And of course, everything else that's relating to the cloner with the set coordinates and so forth, these are the same things: instances, render instances, multi-instances, everything works. So what is a distribution? Well, we can use all the power of scene nodes. Essentially, we can do nodal programming to control the essence of the cloner. So the cloner has the index, the color, the UV, which is essentially the position in space of each clone, weights, which are not generated by the new distributions because we don't need to, and I said color and the matrix, position, scale, rotation. So the index itself here, we can remove it. The source index, we can remove it. These are functions that will be useful as the system becomes more mature. For now, you don't use them. Okay. The ratio is the UVW, where in 3D space a clone resides. Let me give you a very quick example. If we go to the grid mode, and let me bring up this. If you go to grid mode and tell the cloner to present the UVs presented by the cloner, where are my UVs? There you go. The colors that you can see in the UVs over here, little blues and reds and all that, are not real UVs, but it's a way to tell us which of the clones are closest to the center, which are closest to the back, which are closest up and down. And it's a sort of UVW coordinate system. And you'll see these colors change over here. You can see that. So the reason I'm showing that is because in the distribution, in the world of distributions, and this requires forget about the transform for now. I'm going to just turn it off. In the world of distributions, this ratio is what that UVW is. Now, because we are programming things, we can actually put whatever data we want here. So there's no limit to what kind of data we can put, or any. So for all intents and purposes, the ones we're interested in, we don't even interested in the container for now. Matrix, ratio, if we wish to do that, we don't need it. Color, if we need it, and clone type. I'm going to stick with these three, right? Data type, we don't need it. This is the minimum you require to do anything else. Okay, so, and there's a very good question about the Mandelbrot and why I can't connect it and all that. I'm going to explain all these things. So we need to feed this with, click on that, an array of matrices. Where can we get this? Well, we can generate one, or we can read one from one of the existing distributions. If you type distribute, you'll see quite a lot. What I'd like to do is get a distribution op, and because this contains all the distributions available to us. And you don't have to go to the C or, Shift G or C and type distri all the time. You have it here. You make a copy. You choose your distribution, or let's say a trigonometry distribution, and then you right-click on the header and change you toggle the node type. So now you have another one. Let's go and test let's say grid. Make a copy. Right-click, toggle node type. So this distribution here, if you click on that, contains some of these things. And if you click on that input container, this should give you the ability to connect it. But for some reason, it doesn't. And you're going to be looking here. Where's my, I can't find it. The reason is that these are slightly different. If you look at the various parameters here, the source index is an integer. This is what it expects. And here the source index is an int vector and so forth, which makes things a bit more complex. This is the reason why some of these distributions cannot be connected directly. And that's why I removed this. Don't do that. What you can do is you iterate the collection. That's what we do with arrays. You put it here, and now you can get either the individual elements from here or decompose container. A decomposed container, these two things, allows you to see what's inside an array or something like that. So decompose container, write this down, is an interesting way to go to any of your distributions, any one of these, put the decomposed container here, and it will expose what is available. And you will see, look at that, they have different connections. Let's go and get that Mandelbrot, Mandelbulb, or Mandelbrot. Let's get the brot. Control click, right click, toggle node type, decompose container, boop. Okay, and you can see that they're slightly different. That's because these distributions were made purely for nodes, and our system is optimized for MoGraph. So let's go and test the grid. If I put the matrix here, look what happens. I get a bunch of the first clone. And you can see they're all black. So let's go to the cloner and see the color doesn't make a difference here. And that's because the color now is taken over by your distribution. So if there's a color array, these 4 dots mean it's an array. You can do this. So now it's providing us these colors, which is nothing more than the UV positions and all that nice stuff. Okay. So immediately by using a composed container, you have an immediate way of creating some sort of distribution that works directly with MoGraph using one of the built-in distributions here. Okay. So all you have to remember is decompose container, which if I was naming things, I would name it peek inside an array and see what's there. I like these names. Now, if you are working with nodes, select the node, go to Basic, activate the display comments, and type peek inside the array to see what's there. Woot. There you go. Click, and there you go. Peek inside array. And you can actually save this as a preset, right? You can save this as a preset. So all you have to do is just go between whatever you're doing. But it's up to you. You have, I'm going to save this file at the end, or you can just check the other files. But so that you have exactly what I'm doing here. So let me just go and save it. Let's go to December the 3rd and call it session project for building distributions. It's amazing how writing names is the biggest part of what I'm doing here. Anyhow, so in the same way, you can delete these and say, okay, I'm going to do the trigonometry and put the color here because I think, yeah, it offers color. And so forth and so on. And of course, you can change various things about whatever the distribution itself allows you to do, the heights, the widths, and all that kind of stuff. All right, and let's do the Mr. Mandel. Someone wrote a joke there. Never make fun of a broad order worst. Well, oh, that's no, don't joke about people's sausages. Don't. That's not cool. So there we go. Mandelbrot. Fantastic. So it does work. All you had to do was use a decompose container. So now you have the fundamentals of using any one of these. So let's forget this exercise. So I'm going to save this and start. I'm going to save as. I'm going to call this distribution from scratch. Fantastic. So this is a totally new one. And what I'm going to do here is I'm going to delete everything. I'm going to leave this. Or I can even start right from scratch. So we're starting from scratch. So create. There you go. So this is how you will start again. I'm going to delete what I don't need. So I'm going to leave clone type. I'm going to no ratio, no source index, no index. Matrix, color, and color type. So let's come up with a quick idea. I want to create a linear distribution. That's what I want to do. So the first question is, how many clones? Yeah, someone started your Teams meeting. It's not it's not mine. It's just many things are happening while I'm presenting. Okay, so let's see. Where were you? So if we want to create a fundamental number of copies of things, we use a range. A range is the equivalent of a for loop that just creates an ascending series of numbers. So range, that's what it's called. And in the attributes, it's from 0 to end. So if I say the end again is misnomer. This is count. This will give you from 0 to 9. Okay, so it stops at this -1. I think that's right. Programmers are very smart people. Cheers, everyone. Just having some coffee. And they think in a different way. That's why they can make all these amazing things. My brain works differently. So this from 0 to this -1 makes sense for programming, Python and all that. I call this count. So I want start to 0 and count 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyhow, these numbers are going to be spat out here. So we're going to get a rapid succession of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to compose that into a X position. So I need to create what? An array of matrices. So I need to create an array. There are many ways you can create an array. The easiest way is by using an append. what an append does, it takes any value. Let me show you what an append does. An append, if let's say we have an empty array. So this is an array that is empty. And we don't know how many things we're going to put here. And we say, let's append. The append adds something. So I want to append 5 to this array. So this 5 is going to go here. So we have 5. So then I want to append 9. It's going to take this and put it after this. And you can put a 9 and separate these with a comma. I don't know why I put this line here, but anyway. Then I want to append number 3. It's going to take this and put it here, 3. So an append takes an existing or an empty array. So you can have an array that says 1, 2. An array is just the sequence of the same things. Okay. An array of nosemen is a collection of nosemen, and you can add as many nosemen as you want. You cannot add any Ellies because it's an array of nosemen. Okay. So you can take this array and you can say, oh, I want to append 109, the number 109 to this. Then this becomes 1, 2, 3, 109. That's what an append does. And that's as simple as it is. So we go here and we append. It may seem a bit complex, but you just need around 10 basic principles to get started with this. So I want to append elements. And the question is, what elements and to what am I going to append this? So you select the append elements and you say, this is, click on this button, an array. Everything I'm doing now, you can actually save these as presets and bring them up. I'm just showing you that thing, how it works from scratch. So I want to append because I want an array of matrices, right? You go here and you say array of matrices. So you say, I want to append an array, and then you unfold this, and you go here and you say, okay, this says float. Let me go here and replace it with a matrix. And of course, you're going to say, oh my Lord, this is so difficult, all right? And I'm with you. This is not the simplest thing. What you can do, which is a little cheat, remember what has an array of matrices? A distribution. So when you're working with distributions or other things for that matter, go and grab my favorite one, which is surface scale blue noise. Okay. And remember that thing, decompose container, your best friend. And we have an array of matrices. It's already there. So if I append, what do I want to append? Well, go here and expose the data type and stick this in the data type, and it will populate it for you. No reason to go here and find those weird things and all that. Just go and steal one from somewhere. Steal the description, the type. And that's how you do it. You just expose the data type and you just drag it here. And you can see now they're same data types. Good. So step number 1 is done. I have an array of matrices. Good. And you will see here that it's empty. It's 0, 0, 0. Look at that. It's got a matrix 0, 0. Look at that. I have 1 count. And now I can say I've got 2, and they're both on top of each other. So this append elements already is giving me some sort of value right here. But now I want to go and overwrite these values with my own values. And remember, I have this range 0, 1, 2, 3, 4, 5. Let's go down here and unfold our little matrix. We want things to move on the x-axis. So watch how the magic happens. Make some space for magic. All right. Look at this little cone. Right? You can see this little cone here. Okay. I'm going to take the range. I'm going to put it in the x-axis. Ooh, something happened here. Look at that. We have cones. We have 10 cones. We have more than 10 cones now. Oops, I'm checking it out from the other side. I'm viewing it from the other side. So we are creating a cloner, a linear cloner that offsets these by 1 centimeter, because the value here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to make this value bigger. What is that thing that makes a value bigger? It's either multiplication or scaling. So you can type multiply and you can multiply it, or you can type scale, not scale, scale. And there's a nice little scale here. I'm going to use a scale. And you say, well, take this number here. It's scaled down to 0 now. And let's scale it up. Boop. There you go. This is your distance. This is a linear cloner now, where you can control the distance. Wait a minute, what does that mean? That means that if I take the scale and control shift click to get the connection and put this on the Y, now I have X and Y. Oh, if I do the same thing here and put it on Z, I have X, Y, and Z. And here's your linear cloner. This is how you do it. Yeah, I was listening to that song the other day. And yeah, this is the simple way to start creating your own clones using programming. Okay, let's see if we have any quick questions here. I'm sure we have a million questions, but let's let's put my face here. There we go. So where are we? Let's see. Hello. Oh, I'm going texture, UV map, vamp. I'm going to deal with the current questions. Let's see. Yeah, a lot of comments here. Let's see. Okay. 1 sec. Okay. Drake. A cloner advanced nodes grid Decompose container. It looks like the old ZBrush team leading the US. 7 clicks, get a single function. Yes, because it's programming. So it's unfortunately, I would say unfortunately, but it is a reality. If you want to make complex things, sometimes the complexity increases the more granular you want to become. So yes, there could be better ways of doing it. This is the current state of affairs. So hopefully it's going to become better in the future. But believe me, it's just a few concepts. If you are so inclined to get into this world of nodes programming, you will open up doors. And right, here's a bit of advice. My personal advice, the way I see things. I'm going to do this, just for a couple of seconds. So there's a bit of fear out there with the advent of generative AI and images and all that. But anyone that's worked with any client knows that it's the details, it's the revisions, and the ability to deal with very, very specific things by the client that keeps the clients coming back. How efficient people are in doing that. In its current state, for general inspirational looks and look development and all that, maybe generative AI works. I don't use it. I don't really care. But the artisanship people have that allows them to make not only beautiful things, but extremely detailed and precise animations or visuals, that is not, that won't be replaced. That's my personal view. That is my personal view. The broad strokes, yeah, of course, executives are going to be making their own little movies, but those movies won't be to the standard that these executives have been demanding from studios in the past. So I don't know what's going to happen. What I do have to say is that in every historical moment, you can go centuries back. Whenever there was a new technological achievement that took people's jobs, the best of those people still were able to stay in the market and still make a good living. And for some of them, it was a blessing because it removed the lower tiers. So what I advise is, yes, always be prepared, especially with technology. I would advise sharpen your skill sets. Learn the how to do things better, because you're going to be the people that they're going to come to. Whoever produces generative movies, they're going to come to you to fix all these things, and you have to be prepared to do it well, to do it quickly, and charge a lot of money. That's my advice. Anyway, so yes, it's harder, but the harder it is, the less replaceable it is as well. And it's not just the programming, it's the combination of artistry, artisanship, human connection, and everything else that machines can do. Okay, that's my little monologue here. Let's go boop and continue. So there was a question about if we can add time to this, and the answer is yes, we can. I'm just put these down here. You can go and add a time, and you can get this time. Let's go and get a scene time, which is in seconds, and let's scale this so you can get another scale. So I can get my time and multiply it by let's say 20, and if I press play, it should move up, and you can see it's moving up, and I can increase this. So yeah, you can do all these kind of things. Now, one of the examples I was showing is that, why don't we take this? I'm going to remove the Z or Z or whatever, call it, and I'm going to turn this into a sine cloner. Now, again, you can do this using a lot of these things you can do using other ways. There's no question about that. I can get a formula, create a sign, and then clone on that, and so forth. This is just to illustrate that if you do have a unique situation where it requires programming to do, this is a very good way to do it. So let's go to the X. I want, so the Y. I want to get the Y to undulate using a sine from the X, because as the X is increasing, I want the Y to go up and down, up and down. And I know that that is either a sine or a cosine. So type sine, trigonometry. And sine works nicely from numbers from 0 to 1, okay? So this is another one of those things that you need to learn, converting ranges of things. So knowing that in trigonometry, a sine is a wave that goes like this, okay? And cosine is something that goes, I think it starts from here. I don't know. I don't care. It works. So you don't even need to know these things. These are, simple. Who cares why an A is an A? We know it's an A, right? We don't go every time we use an A in a word like Athanasios to explain why the A came to be the way it is. So it doesn't matter why. I know that from 0 to 1, if I feed numbers from 0 to 1 here, I'm going to get a thing that goes from up. So from 0 to 1. This is what I get from 0 to 1. Excellent. But my range goes 0, 1, 2, 3, 4. So I'm not going to get that in between sort of squiggle. So what I need to do is remap this range mappers. I love range mappers. So range mapper. And I want to take this value, and now I want to remap whatever this value is. And remember, the end is 22. I want to say, get numbers from 0 to 22 and convert them to 0 to 1 and put them in the Y. Use them in the trigonometry and put them in the Y. And you'll see that it's so small, you won't be able to see the difference. I'm going to get this and scale it up. Again, we need to scale things up. And let's scale it up. You can see it's creating this like, and from 0 to 22, So let's add a few more of these. There you go. Oh, 3.14, right? The pi. Yeah. Whenever you see things not working exactly the way you want them to, it's probably because pi, whatever. And so it's not from 0 to 1. It's from 0 to 2 pi, whatever. It doesn't matter. You just eyeball it. You know that it's not the same thing. You go and you eyeball it. And then what you can say is, and you see, it takes negative numbers. It takes all sorts of nice things here. It does all sorts of cool things. Now, I want to increase this. You can see it's increasing. And it's going all the way there. Look at that. So basically, what do I need to do here? I control the speed. So 2 times pi. Is that correct? Yeah, kind of. I don't know. Maybe. Does it matter? No. I have a sine distribution. Fantastic. Now, what do I do about the cloners? I want to change the colors, first of all. I want to make them all, I don't know, pink. So we need to create what? An array of colors. Let's go and build array. Another thing you need to remember. You can build an array, or you can fill an array. Or you just type array, and you look at all these things you can do with arrays. So fill array is an interesting one because you tell it, I want to fill this array with colors. And I want the colors to be, blue. And I want to put this array here. And make color blue. There you go. I want to put the colors over here. So I want to fill 100, 200. Let's go and see the colors because it was in hidden mode. So what happens if I make these less? Look at one of the, let's say, things you need to be aware of. Because this array has fewer than what this is commanding, it will only fill in everything that has complete amount of data or no data at all, right? To fix this, all you have to do is make sure that the length of this array and how many of these things you're creating is the same. So you can do this by taking the count and sticking it in here. That number is already available to us. So now it doesn't matter how many I'm going to make. It's going to put that color there. And you can make that color sort of change with every iteration. There are ways to do that as well. But in any case, this is how you'd go about creating a trigonometry, a sine wave distribution using, programming, so to speak. Okay, let's see. Yeah, the UX UI. Yeah, I understand what you're saying, and yeah, it is what it is, unfortunately. Or fortunately, it depends. Some people like this. I don't know. So let's see some questions here because I have more stuff to show. Just want to, and the time flies. Let's see. Where are we here? Yeah, the nomenclature could be better. Houdini comparisons. That's actually quite good. Let's see now here. Let's see. Where are we? Okay. Let's show a few things here. I forgot to tell you to put the word question. Yeah, the other two children. There we go. Demis. So let me show you how you would go about changing the actual clones there. So let's say I want to create an iterate. Let's first go and select it. Clone type. Again, clone type means which clone you can have. So we need an array. Okay. Again, we can fill an array with something. And I'm going to take another fill array. So fill array. I'm going to use the length and get this count from here. So get this. Put this. It's an array of integers. So I need an array of int. There we go. It's an array of int. I'm going to put it here. And if I go and change the value to 1, it's going to select the cubes. If I set the value to 2, it's going to select the spheres. If I set it to 3, it's going to stay with the last one. So I want to do something to this so that it iterates. And for an iteration, you would go for a modulo. That's another one of those mathematical, extremely useful things that we learned at school but don't remember it. I actually forgot about modulo, the one I learned at school, and rediscovered this with 3D. So modulo will give you the remainder. I have a video on my YouTube channel. Go check it out. Get the range. Put this here to fill the value. And 1, 2, 3. You can see now that we have a. Oops. What is my problem here? What am I doing? Yeah, this is not going to work. What is going to work is I need to take the modulo, not fill the array, because now it's filling the array multiple times. I took a variable number and started to fill the array. And every time you do that, it's going to fill a new array. Anyway, those concepts are, let's say, the deeper ones. I want to go iteratively and do this. So I won't fill the array. I will append the array. I want to append. And what do I want to append? I want to remember that stealing the data, I want to get an index. Go here, inputs, data type. So I want an array of integers, because remember, it's 0, 1, 2 to select these things. So I stole it again from here. And you can see, if you click here, what it requires, int and index, it's array of int. So that's good. So let's put this here. And what I want to do is I want the value to be the modulo of whatever that range is. And modulo 3, because I have 3 items. And now I have this undulating thing where this will give you the remainder of the division of the 2 numbers, this one and this one. And it just produces cyclic things like a clock. The clock is modulo 12, because although it's 4 p.m. in Europe is 1600 hours, so that is modulo 12. That is 4 o'clock. Again, go to my YouTube channel and you can check out those things. But now you can see that you have a setup that allows you to programmatically place your cloners, colorize them in whatever way you want. So having said this, and what is the name of this? From scratch. I'm going to save this. And what I'm going to do, just to as the proof of concept for today, I just made this file, and I'm going to go and upload it in today's folder, and it will be available to you in just a few seconds. And I like that. So you can use these to create your own. Let's now go and take a look at some of the examples I've done. And oh my Lord, I had other things to say and I got so carried away, but hey, who cares? You can always ask questions. We're going to do more of these. So this is my sine, but with numbers. I just added more clones, and I'm using the append and the modulo and all that. I just added the time to the range. It's exactly the same thing I did earlier, and it allows these things to move here. So that's available to you, sine wave. So let me close this, and let me close this because we already saw that. Okay, blue noise distribution. Blue noise distribution. So surface blue noise. And here we're going to use the distribution directly because the surface blue noise happens to have exactly the same compatible one. So let's very quickly go do this as well. Let's create a cloner. Let's just put a sphere in the cloner. What I'm going to show you now is how you can connect an object to create some sort of surface distribution. Advanced, create. The distribution that provides all the information to our cloner can have links either by using a child, hierarchy, just like a clone to a cloner, or a link. I'm going to use a link in this particular case. And I'm going to link this big sphere. So go to distribution, now link it because I exposed that link. And what I want to do is get my surface distribution, surface blue noise. And the surface blue noise requires some geometry. And what we usually do with geometry, we first use a transform geometry, pipe the incoming geometry. Again, don't forget, this is the link I have here. And make sure that the matrix is plugged in here. I like to invert these so there's no crossovers. Doesn't make a difference. And if you look at the distribution here, it should be compatible to this one. And there you go. You have a surface blue noise distribution. And you can expose any of these parameters as you wish. So you can go here and add all the inputs. And with alignments and all that, you just drag them over. So you can say, okay, let's put the offset, new input, align, input, restrict select new input. I don't even know what that does. Count new input, sampling count, we'll do blah, 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 input, whatever. Okay, seed. And now if you click here, you have all the parameters over here. And you can link it to any object you wish. And you have a count and sampling, multiply, and the seeds and all that kind of stuff. So this is how quickly you can create your own distribution based on the ones that are here, providing they are fully compatible with that. So blue noise distribution, you should have it in your downloads folder. So, yep, let's close this. So this is another little example where I created a grid distribution that is centered. So that example also exists. So you can go and find it. I don't know if it's the best way of using 3 ranges. This may be conceptually wrong. There are other ways to do it, but it doesn't matter. Just check it out. Okay, this is one I promised my friends on a specific channel I'm going to show, and it's available. So what am I doing here? This distribution here is a reading the vertex map from this. I've got a vertex map over here, which, I don't even need that vertex map here. I can actually have it on a proxy if I wish to do so. But in any case, I just had it there for now. So I can remove this. So I have this beautiful image here, and I'm using this image to create a distribution of text and colorize them using a basic gradient. And one of the huge upsides with the way distributions work, and why one of the reasons we had to go this way to make it work, is that a distribution is aware of the cloner's children and what their sizes are. So if I take this, make a second one and make it very small, and let's go here and create an advanced distribution. So let's create this. Over here, we get this, if I go and I iterate collection or decompose container, decompose container. You see we get the local matrices, the global matrices, the merged meshes, and these are arrays. So for this one, we're going to get 2 elements in our array, the first sphere, the second sphere, and we're going to get their bounding boxes, their names, and so forth. So this information, although the distribution object does not return the actual object back to the cloner, it can use this information to create whatever you're doing, your matrices and all that. That's why we could go and create things like the stacked distribution, because it's aware of each and every one of the children, and it can offset the matrix by that value. So this is one of the most powerful things you can use. It reads the objects that are subordinated here, and it works properly with the cloner. So if you have a null, and under this null you have a bunch of cubes, it will read this object as a as if it's combined, as if it's got a connect object attached to it. So you will see this as the object, this double cube. So that is a very powerful way to use that. And I've used it in my example here, .stipple. You can go here. I'm taking these. I'm just using the count, not the sizes for this. I'm using the count. For whatever reason, I did whatever I did. Anyway, you have the file. You can check it out. The only thing I haven't included is the texture. Just go add your own little portrait. So this here is a question that was asked, I think, yesterday, if the push apart works with the new distributions. And the answer is it does. So I'm creating using the range and the scale Remember, I'm using the scale to move these by a bit. Okay, they're overlapping. You can see they're overlapping. Go and make sure it's very visible. There you go. The spheres are overlapping. And I'm also scaling the matrix, right? You will see that the numbers here, if you go data inspector, one matrix is 1s, 0, 2s, 3s, 4s, and 5s, and so forth. So the matrix the matrix scale is increasing. And because I'm putting the push apart, I'm setting it to 100 centimeters, it will take that scale into account. So the push apart does take into account the proper scaling of the objects. If I make this editable, you will see that each sphere has its own scale. 1, 2, 3, 4. You can see down here. So they're scaled up. That's what the push apart uses to change. So this is the answer for a question that was yesterday, if the push apart works with distributions. But don't change the size. If you do the same thing and you change, let's say, the radius of the sphere, although that's you can't do it directly using a distribution. But if that were the case, it wouldn't work, right? It's the scaling that makes the difference. Okay, let's see, what else do we have here? This is a setup I did a long time ago, and I converted it into a setup right here. And it's surprisingly simple. Let me show you what this does. So I have, let me get rid of lights and all that nice stuff, floors and cameras and so forth. Good. So I just have a motion object and another. This is an animated object, okay? Animated object. And I don't even need the light. And I have this ray casting distribution, which it uses the geometry I've got as the first child. I've got two children. The light, which is just a plane, and the plane has subdivisions. You can see a lot of little subdivisions. And the man, which is just the animated character, right? So this is the man, and that is the light. I'm taking the lights, the light, the first child, the projector, as I call it, and I'm using its transform, so it's facing in a certain direction. You can see it's facing in that direction. And I'm getting the normal direction and each position. And what I'm doing, I'm casting a ray. What does that mean? Is that you use that little position and that normal direction to cast a ray. If this ray goes 500 centimeters and doesn't hit anything, it returns nothing. But some of these, as that ray is flying out, it's going to go and it's going to hit our little character here. Wherever it hits it, it records that hit position and creates a little position matrix. The result of that, and it just repeats for every point in this, for every point in that, what that generates is a bunch of positions for the clone to clone on. And because this updates, and I think I've got this animating, or yeah, it's coming all the way around, and you can see that it's creating clones where you would have light hitting this surface. The first the first position that it would find after that ray hits it. So I can get rid of my little man here, and now I have this, and the light is animating. I can, yeah, there you go. So this would be another application. I had done this without, before we had implemented in MoGraph, and it was a bit more complex. But now the great thing is that you can go and you can add an effector to this. So you can add some sort of random effector to this. And I can never find the random for some odd reason. I found it. There we go. And you can put, a little bit of a turbulence, and we can have both turbulence and the ray. So this is available for you as well. So you can do things like this where you're deriving the standard cloner allows you to clone on objects, which is either a point object, well, a point object basically, on polygons and so forth. Now you can use a combination of objects to generate these positions. So that is a huge benefit when it comes to what you can do in terms of functionality. Okay, the file is available. Go download it. This is, the blue noise cloner. And in terms of performance, it's rather good. So what am I doing here? Count. I've got 10,000 points generated here. Oh, I need to go 10,000 points. Yeah. What else do I need to do? What happened? I thought I had more points here. Anyway, the file's there. Go check it out. I don't know what happened. I thought I would have even more. So this is another one. I purposely used the DNA proteins or whatever those are. And it's sort of putting clones on a spline, but you define the string here. This is how what this is supposed to do. So yes, we can kind of do that, but here it's embedded in the distribution where I'm getting a string value from my interface here. I'm splitting it up, doing some stuff here, and then I'm using that. I have an array here, built an array. This is sort of a lookup table. Lookup table, LUT, and a LUT for light, but this is a lookup table for something else, because I want G to be on the 0 position because it's here in the 0 position. I've created this so that it aligns to this. And then it just uses that string and chooses the appropriate index of the clone, depending on this one over here, and it puts everything on that spiral. So the more I add these letters, G, G, T, T, C, C, and you create even more of these. So that will be another way to create something with a different interface. So yes, we can put text on a spline using the text object, but what we can do now is generate this. We can have different typefaces for each one. If we have more control, maybe we can set up. This took me a few minutes to put together, but if anyone's making, let's say, some protein databases or stuff like that, you can use these kind of methods to make very complex stuff. Okay. And I think this is just another example. I was just fooling around. I had iterate collections not connected to anything, ranges, floats, polygon objects. You can drag objects here sometimes. Why do I have the op workflow? Anyway, doesn't really matter. You can download it and fool around with all these files. Oh, I forgot to do something about our little thumbnail. So give me a second. Let me bring, I'm going to cheat. I'm going to put this here, although this is not really related to nodes, but hey, it's all clickbait, isn't it? So I'm going to do my little photo booth for Dr. Sassy. Excellent. People will think that I made this using nodes, but hey, don't tell anyone, right? But the file is available to download anyway. So no complaining. Let's go through some questions. All right. And that's how Noseman created a T-Rex from random DNA sequence. Yeah, it's scary stuff. It's interesting, and it's just an indication of all the cool stuff you can do taking advantage of the nodes. Now, one thing I'd like to say is, because it is harder than what Sine4D's standard knowledge level is. But on the other hand, we see a lot of people going nuts on the internet about other software. Oh, can do this, they can do that, which is equally as hard, right? What I'd say is, let me know you have the forms of communication. Give it a shot. For anyone that hasn't touched nodes, or anyone that feels disheartened, check out tutorials by Dominic Rockley, by Donovan Keith, and check out, I have some on Cineversity and so forth, because you can use them in particles and all that. Let me know. You can hit me on socials. You can find me on Twixer at NosemanGR, or Instagram. I try to be there. I'm part of a few of the Discord communities. Cinema4D Procedural. What else do we have here? Cinema4D, another one. Cinema4D Procedural, and the 3D community one. So I'm part of the Cinema4D Discord channel. I've actually started becoming much more active lately. So you have quite a few places to find me. You have the online forum, which I'm going to get to in a second. So let me know. I want to get a gauge on how many people would like to watch this more in-depth, geeky tutorial. I'm willing to do elementary stuff. What is modulo? Why do we use it? What are ranges? What are arrays? And all that. There is abundant information, but I can make it very relevant to scene nodes, and show your way around this. So let me know how much interest there is. The Discord channels and all that, I just go search Cinema-4D, Cinema-4D, and C4D-procedural. Yeah, this should be available there. Oh, okay. Let me see, what other questions do we have here? Looking at the questions. I've lost my mouse. There we go. Found it again. Don't worry, everyone. Yep, a lot of people are interested. So the procedural, the Discord procedural, how do I do this? C4D procedural. If anyone knows, if anyone's here that knows about that, yeah, please post something here. Okay, let's see, what else do we have here? One second. I'm just looking at my screen. Okay, question. Why do we need the transform geometry node? Why not just plug the geometry input in the service? Okay, yeah, that's a very good question, and I think it's a good opportunity to kind of talk about a couple of things, including this. Okay, so let's take a sphere and let's make it editable, and let's go and double click on this point. Right? What are the coordinates? 58, 70, minus 39. Now let's take the sphere and move it up. Go to points. What are the coordinates of that point? Huh, exactly the same. So the point positions are exactly the same because they're calculated relative to the object. So if I were to use a distribution or anything for that matter, if I had a nodes, let's say, generator here, a nodes mesh, and I told this nodes mesh to clone onto points, right? This just creates copies. And let's say I would go and say, okay, let's grab my object child. Let's put the geometry here. Sorry, the points here and the geometry. I'm just going to make a little cylinder. Let's make a cylinder. Let's make it nice and small. And let's copy it here. And let's create the geometry. There are my cylinders. It doesn't matter what the sphere is, because the numbers it's reading are the numbers of the local coordinates. So what we do to compensate for this is transform the geometry to the matrix. Boop, there you go. And what that does basically is it changes the values of the points by multiplying the matrix by the position. And this is the correct way to do it if you want to move things around. So hope that's self-explanatory. Now, before we go, there are a couple more things that are in 2026.1 that are going to interest you. Sorry, and have nothing to do with nodes. And yet, they're extremely, extremely useful. So, this one is one of my favorites because it has to do with cloth. And let's take this cloth here. And one of the powerful things we can do with a cloth is we can set the initial state in the dresser. Okay. So let's assume that I'm going to make a copy of this, bring this down to 1, go here. I'm going to make this into cloth as well. Fantastic. But I'm going to go in the cloth and pin the points. Let's go to this one. Let's go and add a simulation connector tag. Let's set it live and increase this. Okay, so what we have now is a little curtain. Okay, good. Okay, I have a curtain. What I'm going to do now is get a little sphere. I'm going to move it here because I need a little mechanism. I want to do something with it. So I'm going to take the sphere again, make it into a cloth, go to the mix animation, pin it, and I want to connect this to everything else as well. So I think that's going to work because everything is on my cloth. So if I go here and I update, boop, I got that as well. There you go. So let's add a few more frames and let's do something. I'm going to get my little sphere. I'm going to go whoop, whoop, boop, boom, boop, boop, boopy doopy doo. Good. Let's say I like this. Stop. I take my the cloth that is simulated because everything else has its absolute position. I'm going to go to the dresser and I'm going to set initial state. Rewind, press play, and it works. This is a fix from previous because the state of connected objects was not taken into account. So you couldn't actually do this. So now I consider this a huge improvement because now you can create your states and just save that initial state where you want it to be, and everything is going to work as you would expect it to. So this is a huge, and let's try that thing. I'm going to do this, save this as a cloth connected sample. And saved, cloth connected sample, and 3, 2, 1. It should be on the server. Just make sure you refresh that page. It should be on the download page now. So this is one of the improvements I really, really like. So let's continue down. Oh, yeah, there's another one. So let's take a sphere and let's take a cube. And I don't think I need to do that. So I'm going to make this invisible. Let's increase the sphere segments just to make it a bit more fun. And let's go to grow shading. I'm going to go, let's see if this is going to work. I'm going to go here and I'm going to, let's make this editable. I'm going to go here and create a normal tag. And in the normal tag, I'm going to drag, I'm going to go fields, and I'm going to use the Phong. Oh, I can't do it. No, data transfer, property transfer, and use the Phong. There you go. So the normals are facing in this way and that way and so forth. So using the property reads now Phong tags as the source, which I find extremely interesting. These don't, oh, those make a difference. Yeah. So yeah, interesting little effects here. Play around with it. So that's the second thing. Right. Next, do you need me to save this? Yeah, I'm going to save it. Why not? We can. Phong in transfer. Phong in transfer. There we go. On the server it goes. And 3, 2, 1. 3, 2, 1. Available. There it is. Done. Next one in the... Okay. Next one is... There we go. This is a bit of a UI change. So let's assume we have a little particle emitter. Okay. And we take the group and we right click to have some Pyro. When we have Pyro on a particle group, now we get a drop down that gives us certain channels, including custom channels, so that we can use them in the emission map. And that you can use them in the density, you can use them in the color as well. So you could kind of do that before by typing the names and all that, but now you just get a drop-down list, which makes things easier to control. I'm not going to save anything for this, so bye-bye. What else do we have here? Let me see. Oh, there's an improvement in the MoSpline when we are in spline mode. Let's say we have a helix in the spline, source spline. If I move this absolute position, there you go. So if I, not this, if I put this back here, if I moved this, they move together. But then if I move this, we would get this weird offset. Look at that, where the point, the center of the world is. It created some chaos. But now we have this little spline absolute position. And now they're just going to match. It's always going to be where that original spline is. So that's a little improvement that will allow you to use most splines a bit better. Just a little click. And let's take a look at the solo. And this is the last thing. And there's been an improvement with the solo mode. So let's say you're not in automatic mode, right? Your viewport solo hierarchy. Let's turn on solo. So you can see that I'm selecting these and it's not updating. There's a viewport solo refresh. Let me go and find that. Shift C, solo, viewport solo on refresh. It's a setting. So now if that's on, you click on it, and with just one, you don't have to go off and on to see it. So it's a little improvement again, but it's quite convenient to just do your selections here and just click this button, and it will automatically update your solo. Okay. Yeah, I think now you have the full image, the full idea of what this update is all about. So let me quickly do my little housekeeping, and let's go and bring up, although the housekeeping I want to do, I did it already. I'm going to do it again. There we go. So you can see today's thing. Let's rewind here, and you can see we have all these new files here. Please go start downloading stuff, and make sure you go to this little link here. Using this link just allows Maxon to know that you found this page from the show. It just adds value to the show. There's some sales going on, about 1.5 days left. You can check here the Maxon events and ask your questions. The whole ask the question thing now is going to become a bit more interactive because we have the ability to share files. But as I said, we cannot share files that contain proprietary things. So we'll see how we're going to work around that. Just use this link to go to this page, and then you can go to the Maxon events, check out what's going on. And of course, Maxon Training Team YouTube channel. Anyone that didn't see yesterday's show with Ellie and Jonas, please go and check it out. It was a great presentation with all the details. And there is new stuff in Red Giant as well. And it's a nice show. And go check out, what else do we have? What's new in ZBrush? And it's Rodolfo and Ian that are showing off some cool stuff in ZBrush. And yeah, go to the Maxon YouTube channel to watch all the amazing presentations. Make sure that you watch the replays here with timestamps and comments kindly provided by a very good friend and mentor, Dr. Sassy. Go check out ZBrush presentations, amazing piece of software. And of course, go to Cineversity to learn all the cool stuff we have to offer. And watch the quick tips. Sign up. You know that the majority of people on the Maxon quick tips are not subscribed on YouTube. Go subscribe. Makes me feel and look better. Just watch them. They're less than 4 minutes. Go do that. Have your families and pets watch them as well. Okay. So yeah. Overshot by 34 minutes, which is good karma. I want to thank everyone. Where's my full? There you go. I want to thank everyone for joining the show. It appears there is interest. So what I'm thinking is maybe we can set forth and do some sort of dedicated live show for high-end things, or arrange some classrooms and so forth. I would love more people to get into the technical direction or technical artist point of view, where not only you can execute your own rather complex ideas, the stuff that other software is usually famous for, but then you check out Dominic Ruckley's stuff and you say, oh, okay, more people can do these things. So more software can do these things. So classrooms or live shows, but please keep the questions coming. And yes, I want to thank you all. Spread the news. Enjoy. I need to go and click those buttons now. And at the end, there's a nice little QR code, which I have no idea where it leads you to. Enjoy, everyone. Thank you for joining me. Bye-bye.